Experiments in Physics with Dr. Frank Oppenheimer. A brief demonstration of the equipment used in the Library of Experiments in Physics, produced in cooperation with University of Colorado Television. Today's experiment
in this experiment, one can measure the moment of inertia of an object such as this rod and several others by exerting a calculable torque on a spindle and seeing how long it takes to get up to a certain angular velocity. It's done in a very simple way. There's a weight which exerts a calculable force on this spindle. The thread passes over the pulley and leaves this so that the thread pulls perpendicular to the radius. One measures time. There's a little platform here. When that's lowered, it starts the counter running. Let's look at the counter. There it's up, there it's down. So that while the weight is falling, the counter runs, and as soon as the weight hits this platform at the bottom, the counter stops. So one can see how long it takes the weight to go from here to here. And from that, one can calculate what the moment of inertia of this rod must have been, or is. Let's just watch that for a minute. One resets the counter, and now I'll flick this and stand back so it doesn't, and as soon as it hits there, stop so it doesn't wind up again, and then I will have gotten the time that it took to go down there. That's the basic manipulation of the experiment. One, of course, has to set things up rather carefully. First of all, this has to be wound in the right direction, and one wants to be sure that the thread isn't slipping. One can put a little piece of tape to keep it from slipping, such as that. And then one doesn't want to wind it up like that, or it'll be not sit in the groove of the pulley and not be perpendicular. But having wound it up, one can again watch one's eyes and then set it on the little platform. Now, in addition to measure the moment of inertia around the center of mass, one can also slide the rod out even as far as one end and measure the moment of inertia there. But clearly, one wants to be sure now that the spindle is vertical and that as this goes around, there's nothing, it isn't falling in one direction or another, and that one can set it here and leave it with absolutely with a minimum of slack in the string. The way one has to set that up is to get the spindle vertical. There's a bubble level on top, and there's several adjustments. There's a screw here and a screw over on the other side of this object. Perhaps we could look at that a little more closely and see it. There's this screw here, and there's a corresponding screw on the other side so that you can tip it this way. And also there's a screw in the back here, which will allow one to tip the axis in this direction. Notice that this stays in wherever I set it now. If I set it over here, it stays there. That's because I've already adjusted the screw. Let me illustrate what happens. Let me turn the screw just a quarter of a turn that's in the back here. You see the rod is sitting right there now. And now I'll leave it there, and I'll turn this screw. It stays there. Now I'll turn that screw a quarter of a turn, or actually a little less, and see how it tilts down. This is a very sensitive level, and I'll put it back. And it's a rather finicky adjustment of the whole thing, and now it will stay there again. I didn't put it quite back. That'll take some time, but it's worth doing rather carefully. Then, having set that vertically, one can go ahead with the experiment and try many different things. One can not only try the rod by itself, about various places, rotating, but one can add weights, either one at a time, so giving the asymmetric situation, or put weights on both sides. There are many different weights provided, but don't add all of them, because that would perhaps be too much strain on the bearing. In addition to the measuring these rather simple configurations for the moment of inertia, you can also use the same device for others. For example, here's a square that's been cut out, which can be mounted on the top here and fastened with two little screws that fit into the holes here, and one could then measure the moment of inertia of such objects or any others that you cut out, provided they're not too heavy. And finally, one can see what the effects of the moment of inertia of the spindle itself are, and any effects due to friction in either the vertical bearing or in the pulley bearing, by looking at the time it takes for the thing to fall. In each case, one wants to be sure that the weight is directly below the groove in the pulley, and that all of the slack is out of this horizontal wire initially, and then I can do that. When I drop this now, it'll fall quite rapidly, and I'll have to put my finger on this, otherwise it'll bounce and the counter will start up again. It's set at 0. I'll watch that. Wait, I had a little slack in there. One wants to set this lever so that the least motion will make the platform drop. And you see that took a rather short time compared to the time required when the rod was in there. Nevertheless, it can be used as a correction for the moment of inertia. I believe that that's all that really one has to worry about in doing this experiment.
Experiments in Physics with Dr. Frank Oppenheimer was produced in cooperation with University of Colorado Television.